Welcome, everybody. Thank you for joining us today. My name is Pablo Farias. I'm the founder of Zenva, an online platform that helps people learn coding and game creation. In this workshop, we're going to go over the basics of the Python programming language. In particular, we're going to be using a library called Turtle, which makes teaching and learning Python much easier. A few words about myself and our company. I'm a software developer and I've been building educational products and online training courses in coding and game development for over 10 years. Throughout all of these years, we've taught programming to over 1 million learners, primarily through our Zenva Academy platform, which focuses on developers and hobbyists and mostly adult learners. But over a year ago, we launched Zenva Schools, a separate platform built from the ground up in order to help teachers with ready-made lessons that are engaging, that are project-based, that are linked to industry, and importantly, that are mapped to the Australian curriculum. So in this workshop, we're going to start by talking about why should we be looking at Python, why is Python interesting, how to install Python, how to get up and running with the language. We're going to talk about the fundamentals of making simple programs and algorithms with Python and how that links to a classroom implementation. And lastly, we're going to have a Q&A section at the end. So please feel free to add all of your questions using the webinar platform that we're in. There should be a question mark button at the bottom. So you can click that and add your questions there, and I will address all of those questions at the end. All right, so why do we need to look at Python? Well, depending on the ranking that you look at, Python will consistently be in the top 2 or top 3, and quite often as the #1 language in terms of popularity. And the reason for this is because of how versatile it is. Python can be used to create websites, web applications, games. It's widely used in the world of robotics and Internet of Things, and in the upcoming field of artificial intelligence. Now, why do all of these people like Python so much? Why are people adopting Python? Well, let's look at what Java looks like. No offense to any Java enthusiasts out there, but that complex code, all that's doing is saying Python and Java on the screen. On Python, that's just a single line that you can pretty much read in English without knowing any programming. You get an idea that we are printing some text that says Python and Java. So the fact that Python is very concise, very simple, makes it easy for people to start using it. And that is one of the reasons why it's gained so much traction and popularity, and why it is a good language to use in schools. But why should we be teaching programming in the first place? Obviously, because we have to. There's the curriculum to follow, but the main benefits here is that students are going to be developing skills that are transferable. One of them being computational thinking, which is taking a real-world problem, deconstructing it, and presenting it into a computer in a way that a computer can then go and resolve that problem. So we are going to be, hitting a lot of issues when you're programming. It's normal to have errors in your code and work through those using, creativity as well as teamwork. And when you go and build a mini game or any kind of project with Python or other languages, you are going to be going through the whole project management cycle, and we cover that as well in our Zenva Schools platform. So all of these skills are very valuable, not only in ICT or computer science careers, but pretty much in all modern occupations that students might want to look into. All right, so we know why Python is important. We know that teaching coding is important, but what about Turtle? Well, Turtle is a library that makes Python very visual and very easy to get an understanding of, in particular when people are new to text-based programming. So let's say that students have done a bit of Scratch so that they can drag blocks and connect them. Usually the transition to text-based programming can be a bit painful for some of them. So by using Turtle, you can pretty much read all of this in English, not know any programming, and you'll get an idea that we are drawing some circles of different colors. So Turtle makes it very easy to start learning Python and to start using Python. That's why we're going to start with that. All right, so setting up Python. That's a common question. How do we actually install Python? What do we need? If you're going to be installing it in your computer lab or in students' computers, what you do is you go to python.org, and you can do this in Mac, in Windows, in Linux, and then you'll find downloads. And in here, you will be able to download the latest file and run that installer in your computer. When you are installing that, it's important to mention, especially in Windows, that you really want to check that box that's not always checked by default, just to make Python available to other programs in your computer. For example, if you're going to be using Visual Studio as a code editor, Visual Studio Code, you will need to have clicked this checkbox. The other option to using Python is using an online editor such as replit.com. So this is a platform where people can do coding in Python on the browser but the issue though is that they do have to create an account. It is free. In our Zenva Schools platform, we also have a bit of an editor there in the lessons that I will show you later that surprisingly some schools are actually using as their Python editor. So I will show you how you can do that as well. But the important thing here is that once you have installed Python in people's computers, to know that it's all running, you should see in your programs, you should see a Python file. And in particular, there should be a program called idle. So I'm going to go and open this idle program. This is a runtime for Python, which means I can write Python code here and execute that code. So the easiest way this is like the simplest possible code editor that you could have. It's just the Python idle. And then what you do here is you create a new file in Python. So I'm going to click File, New File. And in here, we're just going to print. We're going to type print. We're going to open parentheses, which means that we're going to be passing some arguments to this command. And we're going to write hello world. And the reason why I'm using quotes is because that's how we pass. That's what we create what's called a string of text. But we'll talk more about that later. So I've written this here. I'm going to save this file. So you want to save that file somewhere safe in your computer. And I'm going to call this hello world. The extension for Python files is py. All right, so I've saved my file. And then if I go and click run module here or press F5 in my keyboard, that's going to execute that file. That means it's going to run this command. And what this command does, it just says hello world. So that's how you can have Python up and running really quickly. The download of Python is also generally quite quick. All right, so with that said, we're going to be now talking about the basics of Python itself and Turtle in particular, starting with how to draw some figures. All right, so when we are using Python Turtle, the first thing that we need to do is import the Python Turtle library. So I'm going to delete that, and I'm going to type from Turtle space import asterisk. All this means, don't worry about the technicalities. All this means is we are importing this Turtle package into our script, and now we can start using it. So a common way to use Turtle is to draw lines. So I'm going to go and draw a line. By that, I'm going to type forward, and then I'm going to pass. I'm going to open parentheses and tell Python how many pixels I want my line to be. So I want to create a line that's 100 pixels, and then I have to close that parenthesis. So if I save and run this file, so I'm going to save it and I'm going to run it. What it's going to do is open a window like that, and it's going to draw a line that goes on for 100 pixels. Now, a quick tip here: if you're using Visual Studio Code or some other editors, sometimes when you use Python Turtle, the window will close right away. So you run it, you will see the drawing, and it will disappear right away. In order to prevent that from happening, just type done at the end with parentheses, like so. Okay, so we are starting to get a bit of an intuition here that this is running from top to bottom, and that it is simply a series of instructions. So we've gone forward, now we can turn right. So I'm going to type right and open parentheses again and pass the angle. We're going to turn right 90 degrees. And then we're going to go forward again. So let's save and run that. I'm going to press F5 in my computer. And you can see that it's drawing something a little bit different. So by doing this, you could start drawing different figures. You can go and draw, let's say, a square or a rectangle. And you could also draw things like triangles by passing different angle values here. Just like we turned right, we could also turn left. So I'm going to turn left 45 degrees in this case, and I'm going to go forward another 50 pixels. So let's run that again. And you can see that you can start drawing different things. And essentially what Python does, this is just an algorithm, meaning a set of instructions. So we go from top to bottom, and that's all the computer is doing. Now, errors are something that are going to occur, and I will show you how to deal with those. So let's say that your student or you, instead of writing forward, got a character wrong there, right? An X instead of a D. What happens if I run that? Well, we get an error, right? It says that it will tell you which file had the error and in which line the error was, and also what the error is. For example, here it says name for works not defined. Did you mean forward? So what I can do with this information, or what your student can do, is pay attention to which file we're talking about, which line, and what the error might be. So it says line 6. Other code editors like Visual Studio will have the numbers next to each line, but in the idle program, you actually have to find that here at the bottom. It says line 2. So you can just go down until you find line 6, and that's where the error is. And the Python interpreter already told me what the error was, right? So I can fix that, and then the script will run with no further errors. And I've got my drawing at the end. Cool. Another useful thing here is that, well, firstly, if you add lines in between these commands, nothing happens. So that's only done for better readability. I'm not saying that you would add a line in between every command. I'm just showing you that sometimes you will group a few instructions and then you're kind of doing something different. So you will have a line in between. So that's a way to keep it visually a little bit more organized. But also, let's say you did some coding today, and then you come back 2 weeks later, and you have no idea what this was. Well, for that, we can use comments in Python. We can type a hash, and then we can write something for our future self or for our team members, what it is you're trying to do. For example, I could write that I am, drawing a character or something else, and you can add some other note in here. In particular, I can type, for instance, that this is for when we run this file in Visual Studio Code, right? So that's a good practice that I would recommend for your students, is just document what it is they're doing. And sometimes even before you write the code, you can actually write the comments and kind of describe what you're trying to do in a way that's pseudocode, and I will talk about that in a bit. All right, so what else can we do with Turtle other than moving? We can actually draw circles, and you can do that easily by typing circle and then parentheses and pass on the radius in pixels. So I want to create a circle with 100 pixels radius. Then you can save that and execute it, and you can see the circle being drawn here. Let's say you then want to move and draw another circle. You can simply type forward, let's move 100 pixels and draw another circle. So I'm going to copy and paste that. And you can see that my figure here is being drawn. But what if I didn't want this line? I didn't want to be joining the circles in this manner. So I only want the circles. I don't want the line in between them. Well, think of the analogy of a pen or a pencil. So you can start by lifting the pen. And you do that in Python Turtle by typing pen up, parentheses. So you're kind of lifting that drawing pen. And so you're going to move, your cursor is going to move, but you're not actually drawing anymore. But then if you do want to continue drawing, you can put the pen down. So we can add a comment here in case you want to know what that's about. And you will see now that we drew both circles, but we didn't have that line that was joining them. All right, so everything so far looks a little bit dull, I guess. We could add some color to make it nicer. So a way to add color here is you can set what the color of the pen is going to be by typing color with the American notation, and then parentheses, double quotes, and the name. You can use the name of the color, for example, red. And I'm going to close that. So if I do that and execute that code, you're going to see that the circles are now being drawn on color red. And if you want to change your color, let's say I would like my second circle to be of a different color, like blue, that will also change in that same manner. But there are only so many colors that you can easily name. There is obviously a much wider spectrum of possible colors that you could choose, or that your students could choose. So I'll show you here in Zenva Schools. I'm going to go and select the Python topic and go into our Python Turtle course and show you how we can actually do that by using hexadecimal colors. So colors can be represented by using different systems, such as a color for a number for red, green, and blue values. But they can also be represented by hexadecimal values. So in this lesson in particular, we talk about how data, in particular colors, can be represented in different ways. And that is, an example of those being the hexadecimal value. Now, how can you easily get some colors, some hexadecimal colors to play with? Well, if you just search for Hex Color Picker, you will come across one that's on Google itself. But I know that Google is blocked in a lot of the schools. So there will be like a million different websites, and they all have different color like picker tools. So this is super common. You can find one that's not going to be blocked. And then what you do is you copy that color value, and in your Python code, you can actually pass that hexadecimal value instead of your own written value. So now we have that pink circle instead of red. All right, so other than changing the colors, you can also change of the figures. You can also change the background color, and you can do that by typing BG color and then passing a color in the same manner as before, whether it is a word or hexadecimal value. So I'm passing a color named yellow, and you can now see that we've changed the background to yellow. What if you would like to paint the circles? We can also use kind of a similar analogy to what we did with the pen, which is that you initiate an action and then you stop that action. So we can start by typing begin_fill and parentheses, which means that we're executing this is called a function or a method. Essentially, we're executing that command, then we're executing this command, circle, and we now that we've drawn our circle, we want to stop filling that shape. So if you execute that code, you're going to see the circle being drawn, but it's filled up. You might have noticed that when I run this code, you can kind of see as it's happening. So it has a certain speed to it. If you type at the beginning of your program, if you type speed and then parentheses 0, you can actually make it almost instant. It's not actually instant. Like if you add, say, 100 different actions, you actually are going to see them happening one by one, but it is as close as it gets with Python Turtle. Cool. So we filled up circles. We've done a few things, and if you were using Zenva Schools, so the way that we can teach this is we have these screencasts where we're coding and talking about these different commands and aspects of the language. Usually after each video, there would be a live coding bit where you can just run the code that was described previously. And this is where I have seen some schools actually use this as their code editor, because students are able to to download the file they're working on and also upload it again or copy and paste it. In saying that this does not save in the cloud, so it only sort of like saves in the browser. So you would definitely want to download your where's the download bit? There it is. So you definitely want to download your work if you're going to use it in that manner. So I have seen schools doing that when they don't want to install Python or there are other constraints that make this the best option for them. So after you've kind of learned the basics of Turtle, which we've done already, the next step would be to create a project. And we have this mini solar system project. When it comes to building projects in Zenva schools, we follow the project management stages from the curriculum. So we start by defining the project, and then we show students that's important to make a diagram or mock-up wireframe. So you can create a using paper or digital tools. You can describe what your project is going to be like. And then the next step is to use something like a flow chart to write essentially in English what you're trying to achieve. So you don't have to worry about syntax. You can just create like a little flow chart, and you can do this by hand using different programs. And we also have an inbuilt tool here to create flowcharts. So if you go to courses, student tools, UI builder, we have this. This is an open source tool that we've added to our platform. We didn't develop this program, but we've incorporated it as a module. So you can kind of quickly drag and drop different blocks and start connecting them with each other and create your flowcharts, and then download that as an image. All right, so you would start by introducing these aspects for the reason that it helps students develop computational thinking and taking this real problem and deconstructing it and presenting it in a way that computer can resolve. So we will look at things like flowcharts and also pseudocode, which is essentially writing kind of code, but in English. So you don't worry about the syntax, at least not in the Australian curriculum, because in the Queensland Digital Solutions, you actually do have a syntax for pseudocode. But in a way, it allows students to kind of try to get the concepts right. And sometimes you do a bit of a mix where you would do a little, you could use, like I showed earlier, you could use comments in your code to kind of write down what you're trying to do, and then you could code that. So you don't have to worry about the syntax, but you can kind of separate both things a little bit. So the first project that's developed here is using all elements that we have seen so far. It's just a small solar system visualization. So essentially it's a bunch of circles, and you can pretty much read all of this code in English. A couple of other topics I wanna cover today that have to do more with Python outside of Turtle. One of them is that of variables. So a variable is essentially a container where you can store data and also retrieve and modify that data. So let's say that you have a variable called score, you give it an equal sign, and you give it a number. You can give it any name you want, but there are some rules in Python, such as you have to use letters, underscores. I don't remember the rules top of my head, but there's a set of things that you cannot do. For example, you can definitely not have a space in between. All right, so you can create a variable like that, and then you can print that variable on the screen. And let's say you want to modify that afterwards, so you can either directly change its number, or you could also have a mathematical operation where let's say you add 50 to the previous score. So the new score will be the old score plus 50. And we're going to print both of those on our screen. So let's run that. You can see that we've got 100 and 150. So that's kind of variables in a gist. Quite often you will create some variables, and then things will happen with those variables. For example, you could have the today's temperature, and then you could transform from Celsius to Fahrenheit by applying some formula. All right. You can also have variables that are text. Those are called strings. For example, you could have one variable called name, and let's call this John. And you could print something like hello, and then plus name. So we're going to say hello to the variable name in this case, which takes the value of John. So let's execute that, and there we go. So that's variables. And then what you start doing once you have variables is that you can create conditions. That's called conditionals or branching. For example, again, with the score example, I could have a score of 60, and I could have a rule so that if the score is greater than 50, I'm going to paint the background green. Otherwise, I'm going to paint the background red. So I could have if is the command that you use for conditions. So if score is greater than 50, and then you use a colon in Python to indicate that that's the end of your condition, and that whatever comes next is actually going to be what happens if that's true. So if that is true, when I press enter, you can see that there's already been an automatic indentation here. So some space is added. And I'm gonna write background color and set this to green. Let's try it out to see if it works. I'm gonna press F5 to execute this code. And you can see we painted the background green. But if the score was less than that, was 10, we can run that again, and you can see that now it is white. But what if I want to paint it red? If the person, say, didn't pass, or if didn't get the score in this case, then you can type, if you want to run some code that will be executed if this fails, then you can type else, and again the column, background color, and then parentheses red. And if we run that, now you're going to see a red background. But if the score is again 100 or over 50, you would have the green one. And you can have in between sort of, because you could have that if it's over 70, you get green, but if it's over 50, maybe you get yellow. And so for that, you use elif. If you are going to add another condition to the same if statement, you use elif in the follow-up ones. And then else is executed if all of these, if none of these was true, then we're going to execute else. So let's do a score of 55, and we should be obtaining that yellow. All right. So that is those are conditions. That is branching in a nutshell. Another common programming topic is that of, in the curriculum as well, is that of iteration or loops. So let's say you want to draw a staircase in Python Turtle. So I'm just going to type the copy and paste the code here. For the staircase, essentially, we are moving forward, then we are turning right, we're moving forward, and we're turning left. So I'm going to run that, show you that that looks like a single step in a staircase. So let's say you want to have 2 steps. Well, you can copy and you can paste that, and all of a sudden you have 2 steps. But what if I want to have 100 steps? Are we going to do this 100 times? And if we do, what happens if we made a mistake? Well, we're going to have to fix it manually 100 times. So you can see that this is not looking good. In programming, whenever you see the same thing many times, if it's more than a couple of times, it usually means that you might be doing something wrong, or that, no, I take that back. There's nothing wrong there. It's just that there is an easier way to do it. And one of those easier ways to do it is a loop, an iteration. There are different ways to do this, but I will do what I find that is the easiest, which is a while loop. Firstly, we want to keep track of how many times we've done this. So we haven't drawn any steps yet in our stairs. So I'm going to create this variable called counter and give it a value of 0. So what you do then is you type while, and while counter is less than, let's say, 20 times, if we're going to draw 20 steps. While this is true, then I want to be drawing steps, and I also want to be increasing that counter so that eventually we reach that 20. So what you do here, because we want to be inside of the while loop, we actually have to press tab to kind of indent this, to place it inside. That's how Python knows that all of this code belongs to this loop. And we definitely need to increase our counter by 1 each time so that eventually we reach 20. Otherwise, you would have what's called an infinite loop, and that could actually make my computer crash and I would be kicked out of the webinar. So let's not do that right now, but you're definitely welcome to try it out. I don't think actually my computer would crash. I think there is some sort of, it will force the closure of that program. So you can see that we were able to do something many times, and that's what iterations do. The last concept before we go into a bit more classroom stuff and also the Q&A is that of functions. So we saw earlier that I printed that we have the name and that I was able to print that like so. So essentially, this print is and done, and all of these things we've used, circle, forward, they're all functions that are essentially routines that have already been prepared, and that you pass an argument to them, and then they will be executed. So let's say we want to create a function that's called say hello. Then what you do is you type def space, and you give your function a name. Let's call it say hello. My function will always take some sort of parameter. So I'm going to type, who, but you can give it any letter, any name you want. Let's say that this is, who we're going to say hello. And then we use the colon again. And this function will just say hello, hello, and then it will say hello to whoever we pass in here, okay? So if I just go and run this code, nothing will happen because we're just creating a recipe, but we're not, it's like, this is the recipe to make a cake, but we're not yet making a cake. So nothing's happening. Well, in this case here, because we're no longer in turtle. So I'm gonna delete that. So then what you do is you can execute your function like so. Say hello, and then pass some name. So you can pass different names, and you can call your function as many times as you want. Like so. So if you execute that, you're gonna see, let's delete that done. So you can see that I got an error. It says that done is not defined. It's because I deleted the turtle import just to keep it really, really clean here. All right, so those are functions. So in Zenva schools, firstly, we have 2 courses on Python Turtle. The first one kind of covers up to this point. Those 2 courses are mapped to curriculum version 9 and version 8.4. We have, for both of them, you can download documents that have been put together by the teacher that's working with us, and that will have all of the content descriptors and all of the outcomes, as well as rubric criteria, like some suggestions on rubric criteria. But also we have like a full-blown unit plan that if somebody wanted to use this, it's an 8-week plan. Teachers, of course, are welcome to cherry pick what's useful to them, but this essentially has like a full year 7, 8 band. All of the content descriptors are included, and it's got a like week lesson by lesson activities with the Zenva resources and extra resources and class group projects that you can do and things like that. Python Mini Turtles is the second course in the series, and this also has all of those elements. This one goes over those more advanced topics that I showed you, like variables, operators, conditions, how to debug your code, functions, and there are 3 projects in here. All of them have the 4 stages of project management that are in the curriculum. So all of them will have the diagramming, the flowcharts, and the pseudocode, as well as challenges and quizzes, and the unit plan as well has like a lot of ideas. So the first project here is this balloon popper game, where you're just popping balloons. So you can see that Python Turtle can also be made interactive. And all the things here we have seen in one way or another. So they have to do with functions. We haven't seen user input, but that's all here. And so that's the first project. Then we also have a Starry Sky and a mini game. So the Starry Sky is just to teach loops. So we're drawing stars in a random manner, and then the turtle mini game, you can command this turtle, move it around, and take it to the ocean, and then you win the game. So you can obviously then go and you could combine a lot of these elements. For example, you could take this type of project and ask the students to add trees or grass into the turtle project. So there are a lot of things that can be done here. And if you're curious as to how other schools have been using it, if you go to schools.zenva.com and then case studies, there's quite a few of those here. But in particular, there was one that is Park Ridge State, which actually used by the same Python Turtle course. So you'll be able to find there some tips that the teacher has shared and how they have run this on their own end. if you are looking to find what's the curriculum mapping, but you don't want to go to each one of the courses, you can also find all of that here, curriculum mapping Australia, and you can choose your curriculum. Our digital solution coverage is only very limited, but with 8.4, we have full coverage. With version 9, we have a lot of it. So you can then find, and if you're ever, looking for how can I teach content descriptor A, B, C, D, you are highly likely to be able to find it here. And you'll find the link to the course as well as the link to the course mapping document that the teachers put together. So we have a little bit of time, so I thought this would be a good time to do our Q&A session. So if there are any questions, feel free to add them there on the platform. Questions about any of the things that we've gone through today. So we covered a lot of ground. We've learned drawing commands, variables, conditions, branching, loops, and the webinar recording will be emailed to all participants so that you can then watch it again if you want to, because I did rush through a whole lot of the concepts. So you will also get that video. So I've got a question here. It says, Turtle looks very easy to use. How powerful is it in comparison with Pygame or Phaser for game or animations? So good question there. So I will cover both of them. So firstly, Pygame is just a much more advanced library for Python development. So somebody starting Turtle, they could be totally new to programming. So they could really be fresh off like scratch. Pygame, on the other hand, I would recommend that they have done a little bit of text-based programming. So maybe start with Turtle, and then you can transition into Pygame. And let's see. I don't think we have the live snippets here yet. That they're on the pipeline. But essentially, Pygame is a much more advanced library where you're dealing with frames. So you're doing different things, say 10 times, like each frame, you are drawing things again on the screen. So you're like, it's much lower level. In Turtle, you drew a circle and you don't have to worry about it again. In Pygame, you have, you're working at a lower level where you're drawing things that are drawn once and then things that are redrawn on the screen. For example, if your character moves, then you have to redraw everything. On the other hand, Pygame has a lot more features like user input, and it's not used by, as far as I'm aware, by many like professional games, but you can definitely make much more advanced games. There's a huge community. Now, Phaser is a completely different animal because Phaser, I think we have it here. Phaser uses JavaScript, so it's a different programming language, and also Phaser runs directly on the browser. So let me just see if we have that here, and if not, it might be here in additional courses. But it could also be that it's in our Zenva Academy platform, so it might not be in Zenva schools actually. But essentially, if a school wants to use Phaser, we can easily bring that in. But on a nutshell, Phaser uses JavaScript. JavaScript runs on the browser, and Phaser is used to create like web-based games. But you can also like pack them for mobile. For a good Phaser introduction, you can visit our blog, phasertutorials.com, that has a lot of tutorials on Phaser. So this is one of our sites, and Phaser is definitely a lot of fun, but it uses JavaScript instead of Python. Do we have any other questions? So with that said, if there are no more questions, I really want to thank everyone for attending. I hope that you found it helpful or useful. If you have any feedback, please let me know. And if you are looking to trial our platform, you can request a free trial there on the link, the school's website. So thanks again. Have a good night, and I will see you in the next one. Bye.